Today we'll be looking at slope of a line. Key concept, slope. That's what we want to talk about today. Remember, the slope of a non-vertical line is the ratio of the rise to the rise over the run. You remember that. And we use M to stand for the slope. Let's say we have 2 points, x1 and y1, and x2, y2. Then all we need to do to find the slope is to take the change in y and divide it by the change in x, as you can see with the formula at the bottom here, and you can see also on the graph. Remember that we had 4 types of slope that we've discussed in class. Positive slope, where the line goes up from left to right. The negative slope, where the line goes down from left to right. Horizontal line, and the vertical line. Let's say we want to find the slope of the line that passes through 4, 5, and 7, 6. The answer is C. And why is the answer C? 6 minus 5 is equal to 1. Notice the 6 is the second y value and 5 is the first y value. So y2 minus y1 is equal to 6 minus 5, which is 1. And then 7 minus 4 is 3. I'd like for you to try this one now. Find the slope of the line that passes through the points -3, -5, and the point -2, -7. You should see that the answer is B. And let's see why. Notice that when you do the substitution, it's important to know that when you subtract the negative, that you still have to put a subtraction sign in front of the negative, because you're supposed to always find the difference of those values. So make sure that you do your math right, and you subtract the -5 from -7, and you get a -2. And -2 minus -3 is a +1. And that's how we end up with the slope of -2. Be very careful. When using a graphing a line and finding the slope of a line using a graph, especially one against a grid, it's helpful to find intersections between the graph and the grid. And some of those, we call those bullseye points. Here's one at 0, 2, and here's another one at 4, 3. And we can go ahead and label those. And let's put them in the table or a T-chart. And of course, we can subtract 2 minus 3 is -1, and 0 minus 4 is -4. And a -1 over a -4, the negatives cancel out and you just end up with 1/4. This time I want you to find the slope of this line that's in the diagram there. If you look at the bullet points, you'll find out that one of them is at -4, 4, and 0, -1, which if you subtract those, should give you a slope of -5 fourths. You might notice something about 0, -1. You notice what the y-intercept is? It is a y-intercept, so the y-intercept is -1. Now we have the slope and the y-intercept. What does that enable us to do? We can write the slope-intercept equation of the line. So now we can write the whole equation of the line. In this case, is y equals to -5 fourths x minus 1. We will revisit this again later on in the video. All right, let's solve the proportion n over 12 equals to 3/8. We write the proportion, use our cross products. When we find the cross products, we can write our cross product equation. Let's simplify that equation. And let's isolate n by dividing both sides by 8. And that's how you get your answer. N is equal to 4.5. Okay, I'd like for you to try this one. Let's Suppose we have the proportion r over 9 equals to 7/10, and we solve that for r. What would we get for r? Would it be 10, 63, 6 3/10, or 10, or 70? The answer should be 6 3/10. Let's see why. First, here's the original problem. Let's find our cross products. That's 10 times r times 7 times 9, which is, equals 7 times 9, which we know that's 63. And now to solve for r, we divide both sides by 10. And that's how we get r is equal to 6 3/10. Hope you were successful there. Let's use proportions in order to solve this equation. Okay? First thing we need to do is write the problem. And we can use our cross products here. We're going to multiply the 4 times the x plus 4 and the 3 times the 12. And that gives us an interesting binomial times monomial on the left. So that's the distributive property. And 12 times 3, which is 36. So x plus 4 times 4 is 4x plus 16. Make sure you distribute that 4 to both the x and the 4. And now that we have our two-step linear equation, we can subtract 16 from both sides. We do that, we'll end up with just 4x on the left and 20 on the right. And if we divide both sides by 4, we'll get x is equal to 5. Let's try and solve this proportion. Ready? Correct answer is 16. Let's see why. Here's our original problem. Here's the results of the cross multiplying. Let's simplify those results. Make sure we use the distributive property on the left. And 5 times 16 is 80. Let's go ahead and solve for x. Let's use our additive inverses or our zero pairs. Get rid of our zero pair to 48, negative 48. Keep our equal sign straight. All right, isolate the 8x on the left, 128 on the right. Divide both sides by 8 to isolate x. And your result is x is equal to 16. Now let's see if we can apply what we've just done with proportions and cross products to this new problem here. Find the value of r so that a line through 6, 3 and r2 has a slope of 1/2. So I'm going to let my 6, 3 be my x2 and y2, and I'm going to let my r2 point be my x1, y1. And I need that to be equal to 1/2. So here's the equation if we substitute in. We'll substitute into this formula right here. Keep in mind we already know what the slope is. We know that m is 1/2. And y2 minus y1 is the same thing as 2 minus 3, where I let 2 be my second y value and I let 3 be my first y value. And then I don't know what my first x value, my second x value is, but I do know what my first x value is. So I'll substitute those in. And then I just need to do, this is where we need our cross products. Okay. Well, first we'll simplify because we do know what 2 minus 3 is. And that's negative 1. Apply our cross products. Right. And we simplify our cross products. All right, now we have a fairly simple equation to solve. We just add 6 to both sides. And once we do that, then we know that negative 2 plus 6 is 4. And that's our answer. Now, I'd like for you to try this one. Hopefully you got the correct answer of negative 5. Let's see why. All right. Probably not a good first step. Actually, that's a pretty good first step. Substitute it into the slope formula, okay? and I want to keep all my equal signs straight. So let's simplify that numerator. Let's do our cross product. 5 times 8, the negative 5 times the p minus 3. I could have placed a negative either with the 5 in the numerator, 5/8, or I could have put it on the negative 8 or the 8. Either way, it would have been fine, as long as it was on one of those numbers. And then let's simplify both sides. Distribute the property on the right this time. Okay. Let's subtract 15 from both sides. Start isolating that p. And simplify. Divide both sides by negative 5 to get rid of that negative 5. And we end up with p is, the answer p is negative 5. Remember, there are 3 forms of linear equations we've talked about this year. This one. Remember the point slope form, which is good when you don't know what the y-intercept is and you have 2 points. Well, actually not 2 points. When you have a point and a slope and you don't know what the y-intercept is, this is a good form to get started with. Then there's a slope-intercept form, which we're very, very familiar with, our go-to formula, because it easily tells us we can easily pick out the slope and the y-intercept from this form. Now, standard form, you're actually going to see more of standard form once you get past algebra 1 more. But for right now, we're going to just focus on standard form for the purposes of converting it to slope-intercept form so that we can find the slope, because it is not obvious that what the slope of this particular line is from the equation. So we're going to use reverse operations to solve for y and to rewrite this slope-intercept form, as opposed to graphing and finding the bullseye points like we did earlier. In an earlier example, we actually had the graph of the equation in order to find the slope. What happens when we don't have the graph? Well, we can just isolate the y. We can use the inverse operation to isolate the y. And once we've done that, the equation will be in slope-intercept form, and we can just read the slope and the intercept. So let's write the equation. And let's begin isolating the y. 3x needs to go. Subtract that from both sides. Let's keep our equal sign straight. And simplifying the left, get rid of the additive inverses, we bring down the 2y. And because 6 and negative 3x are unlike terms, we can't do anything about those. So what we do discover with 2y equals to 6 minus 3x, we're almost done. All we need to do to isolate the y is to divide by 2, which is exactly what we're going to do. The 2's are going to divide out. 6 divided by 2 is 3, and of course we can't reduce the negative 3/2, so that means our final answer, our final equation in slope-intercept form is going to be y equals to 3 minus 3/2 x. Since the coefficient of x is a negative 3/2, then that lets us know what our slope is. But the question is actually asking for the entire slope-intercept form, which we do have. So which one of these looks like that? Hope you chose A, because that's exactly what the answer is. Let's find the equation of the line that passes through the points 4, 3, and 0, 2. The point 0, 2 is a y-intercept because x is equal to 0. So we can use the slope-intercept form to get an equation of the line passing through the points. 2 steps. First step, find the slope. There's a slope formula, and let's substitute into it. Substitute your points in the slope formula and simplify. Get 1/4. Step 2, since we already know the y-intercept is, we already know it's 2, we can immediately write the equation in the slope-intercept form. Y equals 2mx plus b, or y equals 1/4 x plus b. Now I want you to try this one. Let's find the equation of the line that passes through the points 5, 1, and 0, negative 5. The point 0, negative 5 is a y-intercept, so we can use the slope-intercept form to get an equation of the line passing through the points. First step was to find the slope. And second step, since you already know the y-intercept, you just immediately write the equation of slope-intercept form. Hopefully you did well. Here's another scenario. Suppose we want to find the equation of the line that passes through the points 4, 5, and 7, 6. Note that neither one of these points is a y-intercept. And since that's the case, we need to use the point-slope form to get an equation of the line passing through the points. So here are the steps. First, find the slope as usual. All right, after we found the slope, then we need to choose one of the points. I'm going to use 4 and 5 because it's smaller, I guess. And then once we have the point and the slope, we substitute into the point slope form. And then we need to simplify after that. Let's see if we need to, we'll see. So if I substitute the 5 for the y1, the 1/3 for the m, and the 4 for the x01, I have my equation, the line in point slope form. I mentioned earlier that you can use the point slope formula in order to find the y-intercept. In order to do that, you need to actually convert it. And you can convert point slope-intercept form with 2 steps. First thing is distribute the, basically simplify it. So distribute the m value or the slope across the parentheses on the right. And then once you've done that, the next thing you do is isolate y. So once you isolated the y and you combine your like terms on the right, you will arrive at the slope-intercept form. And now you know the slope and you know the y-intercept, even though you didn't know either at the beginning. Got one more equation for you to try. Find the equation of the line that passes through the points -2, 4 and -7, -3. Now notice that neither of the given points is a y-intercept. So we have to use the point slope form to get an equation of a line that passes through these points. So step 1, find the slope. Let's substitute our values. And once we simplify our fraction, we get 7/5. Now we're going to choose one of the points. I decided to use the point -2, 4 because there's only one negative to worry about in it. And then we'll go to step 3, substitute your point and your slope into the point slope form and simplify if necessary. So here's a point slope form. Let's do our substitution. 4 is y1, 7/5 is m, and -2 is x sub 1. Okay, now notice that we're subtracting a -2, but that's the same thing as adding a +2. So we can simplify that last statement like this. And that is the equation of the line that passes through these 2 points in point slope form.